So for a quick introduction, my name's Alexis Smith. I manage developer partner programs at Dfinity. And what that means is I work very closely with our strategic development partners that are working on apps and kind of navigating our software developer kit and the Motoko programming language, which we'll talk a little bit about later. I'm also kind of an interface to the broader development community that's providing feedback on the developer resources that we have released and that they're starting to interact with and build applications. And before Dfinity, I actually ran an enterprise blockchain lab at BASF, which is a big chemical company. They actually have a presence here on campus as well. And before that, I actually got into the blockchain space back in 2015, focusing on impact use cases. So I know you have a social impact focus for this class. And I was looking into carbon credit tracking back in 2015, which was a pretty early use case at that time. But yeah, I'll hand it over to Hans for a quick intro.
Hi, my name is Hans. I worked as a senior software engineer at Dfinity. Before that, I was at Google for 4 years working on Angular. And before that, I was working at Slack. I was employee number like 40 or something like that. And I saw them grow to like 250 employees. So yeah.
Awesome, great. So starting out a little bit about Dfinity, we are actually a not-for-profit foundation. We're based in Zurich, Switzerland. And Dfinity, the foundation, also oversees research centers in Switzerland and then also here in the Bay Area, both in Palo Alto and San Francisco. And really the goal of Dfinity is to build and support the internet computer. So most of our talk today is going to be talking a little bit about what an internet computer actually is and what some of the benefits of the internet computer are. So before we start digging into what an internet computer is, it's actually helpful to go back and talk a little bit about the internet and sort of how the internet has evolved over time. So back in the 90s, for-profit companies like AOL and CompuServe actually had the idea that they could close off the internet and charge people for using it and for developing on top of it. And so at the time, in the early 90s, AOL was charging by the hour. They eventually started charging sort of by the day and the month, until eventually they were sort of phased out by open internet protocols. And developers ultimately chose to build software and services on these open protocols, which led to sort of the vibrant tech ecosystem that we have today. But everyone kind of knew at that time that the internet couldn't stay sort of the way it started and that it would eventually evolve over time. And Bill Gates actually predicted this, that the next kind of successor for the internet would be something called the information superhighway. And what he predicted was that basically a handful of corporations would sort of own the internet and start taxing every transaction made on the internet. And he said that the implications for this would be really bad for consumers like us and really bad for business. And unfortunately, he wasn't very far off from the way the internet sort of looks today. Tech giants have sort of hijacked the internet from all angles. So most of the internet services today are built on top of proprietary cloud solutions from the tech giants, Google, AWS, and Microsoft Azure. And sort of the innovation that we're seeing and the software that's built on top of the internet is becoming increasingly monopolistic. And so really what we're seeing is that the space for innovation is shrinking because of this. And so at Dfinity, we're committed to building the internet computer, which we hope will sort of restore the internet to its original roots of being this dynamic, collaborative, and innovative ecosystem. So one of the problems that the internet computer is striving to address is something called platform risk. So we'll talk a little bit about that. So as an entrepreneur, you are increasingly having sort of less options of how to build something novel and new. And until recently, many entrepreneurs would actually leverage the APIs of some of these large tech companies. And over the last 8 years, many of these companies are starting to cut off access to their APIs. So Twitter notoriously did this in 2012. Salesforce did it in 2015. And basically, if you were an entrepreneur leveraging these APIs, you were basically cut off and your idea sort of died on the spot. And there's some pretty prominent examples of this. So when Facebook changed its APIs, Zynga actually lost 85% of its market cap. So back in 2011, Zynga was leveraging Facebook's APIs for their games. And at that time, they actually made a statement that they were hoping to move away from Facebook, which is when Facebook offered them sort of a nice ad revenue sharing model that kept them around. And then shortly after that, APIs sort of, Facebook pulled the APIs from Zynga and kind of ruined their market cap. This happened again with Google and Yelp. So when Google changed the rules for search, Yelp actually lost 84% of its market cap. So I'm sure as consumers, we've all noticed that the Yelp results have sort of fallen down. And now they're sort of below Google Ads and Google Places, to the point that Yelp is sort of losing traction in the search space. And ironically, many of these large tech companies are beholden to large tech as well. So 17 out of the 22 recent tech IPOs cite Amazon and Google as existential risks to their business. So if you actually look at these S1 filings, you can see that Lyft cites AWS as a dependency for their business. Uber is citing, the Apple App Store, Google Play, Slack also citing AWS. And so what we're seeing here is that, the space for entrepreneurs is shrinking, and that also these dependencies are basically just boxing out any sort of new technology. And actually, big tech is sort of beholden to big tech in some ways. And this isn't news. It's, the headlines, tech giants have hijacked the web. It's time for a reboot. Tech monopolies are a cancer for American capitalism. So everyone is sort of waking up to this idea that the internet has become something that we did not intend it to be. And so enter the internet computer. What we're aiming to do is allow the next generation of developers to take on big tech and create an open and free internet. And so let's just paint kind of an analogous example between the internet and sort of what we're building with the internet computer. So the internet is actually made up of a bunch of different independent networks that create a virtual public network. And the thing about the internet is that it only creates connectivity, so it only offers up connectivity. But in order to build sort of the software and services that we have today, you basically have to cobble together this Frankenstein kind of information architecture and IT stack to allow you to actually run software and services as we know them today. And so on top of the internet protocol, we see things like databases, cloud, web servers, things that we've sort of had to cobble together to get the functionality that we're looking for. And on top of it, it's not very secure. So we've had to invent things like firewalls and VPNs to make these systems more secure. And what this has resulted in is highly complex IT stack. It's really costly, and there's a lot of kind of room for security hacks. And with the internet computer, instead of running on independent networks, we're actually running on independent data centers from around the world. And these data centers are running what's known as the Internet Computer Protocol. And this is a cryptographically secure protocol that you're actually able to just build secure software directly on top of the protocol. So developers can basically deploy code directly to this virtual public computer. And so what this means is we're able to build sort of traditional IT solutions like websites and enterprise systems. We can get into some of the more interesting use cases for blockchain, such as pan-industry platforms where industries can kind of cross-collaborate, smart contracts, and DeFi systems. And then something that we're really excited about and that we'll dig into a bit more today is open internet services. So talking a little bit about LinkedUp, which is a demo app that we created and presented at the World Economic Forum meeting in Davos in January. So this was an app that we built, it was built by 1.5 engineers in 3 weeks. And we gave this live demo running on our Bronze network, which is basically a demo network that was running on an independent data center in Switzerland. And LinkedUp was sort of the first example of what we talk about as an open internet service. And what this means is it's inherently secure and has a simpler architecture just based on the fact that it's being deployed to the internet computer. It's also ownerless, so a company like LinkedIn doesn't own the platform. It's completely ownerless, and also offers permanent APIs. So some of the issues that we talked about where companies can pull access to APIs. This could never happen with a solution deployed to the internet computer, based on the fact that the creator might say that these APIs need to be marked as permanent in perpetuity, or there could be a governance system placed in the system where the network basically votes for updates to the application. It also allows for enhanced user protections for our data and sort of how these applications are running in the background. And I think one of the most exciting things is that this model actually lays the foundation for truly autonomous systems. So in the blockchain space, you hear a lot about autonomous systems, and this actually is sort of the foundation that is required, where you can basically create the same applications that we use today as consumers that are broken up into microservices and what we like to refer to as software canisters that can sort of codepend on each other. And this really leads to that internet that we all wanted in the beginning, where entrepreneurs can actually leverage one another's work and create new applications on top of existing work from other developers. And so this is just a simple diagram of sort of what LinkedUp looks like under the hood. It's actually very simple. If you look into kind of what an app looks like today, it's kind of crazy with the web servers and the databases. And you'll see here that there's actually no database. All of the functions for the whole app are basically hosted in these two canisters. And what a canister is, if you're familiar with a software container, it's very similar in concept that it holds the application code that actually makes the app run, but it also hosts state. And so it's basically maintaining a record of transactions and information that's flowing in and out of the application. And in the case of LinkedUp, the front end assets, so the things that we as users are used to accessing from a browser, are actually held in the LinkedUp canister and can be accessed from a normal browser, which is really exciting. And I think the main thing I wanted to point out here that's really interesting is in separating this app into two canisters, we're basically pulling apart the functionality that we might expect from something like LinkedIn today, where LinkedUp is sort of the profile management piece of the app, and Connected is the social graph piece of the app. And the reason why this is really cool is you might want to build, say, like an event planning application, and you would be able to actually leverage the Connected canisters social graph and build new applications that could leverage that same social graph information. So in kind of teasing the app out into two microservices, you're able to sort of foster this, this kind of dynamic and collaborative way of interacting with the canisters. And this is the front end, and I think when you see it live, it's really cool, because basically this is the inner canister calls happening in action. So all of the connections are actually coming from that social graph canister that I mentioned, and the resume information is coming from the LinkedUp canister. And when we demoed this at Davos, the user experience is basically that of a centralized system. You can't really even tell the difference, which is super exciting. Great. So with that, I'm going to hand it over to Hans to walk you through some of our developer experience work and to walk you through a demo.
Okay. Hi, everybody. I'm here to talk more about the developer experience of the internet computer. So as you learned, this is decentralized. This is a decentralized platform to build kind of services, open services and open applications. And so the best thing about an open platform is that the most important thing about an open platform is really the developer experience that can really make or break a platform. So we're really working really hard to make that developer experience as best as possible. And this is me, arrow to make sure that you don't confuse. But and so he broke it. Oh. I'm just going to go through that then. So I'm going to talk about 5 things here. The first one, of course, is we have a suite of developer tools that are currently command line, but we're trying to make them as easy to use as possible. And then in the future, we'll bring up GUI so that you can just click a button and start deploying your apps or making new apps or awesome stuff. As the developer experience team, we're also responsible for giving you power to run your own node, essentially your own cloud locally on your computer, which really is different from AWS or Google Cloud, which you kind of need their infrastructure or a special infrastructure locally that is not the same as you use on their cloud. Basically, when you develop on the internet computer, you actually have an internet computer on your computer. So it's a local internet computer. We also are responsible for building and maintaining Motoko, which is a language that was built specifically, I'll get into that, that was built specifically for the internet computer. And we'll show a little bit of that. We're responsible for maintaining and building libraries and APIs for you to use. So this is like more technical experience. And of course, everything that's support and documentation. So just talking a little bit, we have a DFX, which is our main command line tool. You can download it. I'll show you how later. But it allows you to create and manage Dfinity projects and manage your development environment. It can communicate with the main network that's available on the internet, or a local network, or the local network of a friend, or the local network of your company if you want one, test network. And it will manage and help you manage your identities because you need an identity to communicate with the internet computer. So it helps you manage it and maybe create one, et cetera, if you need to. And it's for simple projects, this is really the only tool that you're going to need. If your project grows over a certain size, of course, DFX will be useful to still communicate with the internet computer, but it can be part of a bigger tool chain for a larger team. And of course, we provide all the tools. DFX allows you to run locally your own internet computer on your own machine. It's actually running right now, but we'll get a little bit into the deeper into this in a little bit for the demo. And Motoko itself, it's optimized. It was created for the internet computer, so really it targets running on that platform. It's a simple language that seems seems familiar. It's seamless. It's safe. It has a lot of special things specifically for the internet computer, and but it's not mandatory. You can use any language that targets WASM. If you guys are not aware of WASM, you don't need to know what WASM is either to understand the internet computer. But essentially, WASM is just a container kind of thing. So it builds your code into WASM, and then you can run it on the internet computer. And we are responsible for creating libraries and APIs for a different language. We support different language, so like you can run your apps. You can have a front end that talks directly to the internet computer, for example, using JavaScript, and or you can have like Node or Rust or other languages that can talk directly to the internet computer. And we also have integration with IDEs. For things like syntax highlighting and bug, like showing up bugs in your software. And we're responsible for running the support and documentation, which you can find at sdk.dfinity.org. This goes directly to that. You're going to have a section about how to install DFX and how to get started too. And we do have a forum for open discussions. If you have any question, we are monitoring that. Alexa is monitoring that mostly. I'm there sometimes. But if you have any questions, you come. We have a community that's very friendly, that's growing. I don't know how many members we have right now, but
yeah,
I don't know.
Like over 200, I think, on the forum right now.
Over 200 on the forum right now. Well, that's much more than I was expecting. I think last time I checked, it was like 50. Yeah, you're always welcome to join our community. We do have every other week. Oh, that thing started. Every other week, we do have a live streaming with yours truly. of how to build on the internet computer, and we posted on YouTube the week after. Basically, we're kind of in cadence, like live 1 week, edit a week, and then post it on YouTube the week after, and then switch. We are building a blog engine, so if you know about Ghost or WordPress or any of those, we're building one that's open and will be open source and will be coded live entirely. I'm not cheating. I'm not coding anything on the weekends or just adding little lines of code in between streams. I'm starting when it starts and I'm ending when it ends. So a lot of pressure, but so far so good. And I'm going to show you a little demo of what the internet computer is capable of. This is, of course, all local. It's all happening on my own computer. We do have a demo network to test like an actual cloud inside the company, but we're going to release something a little bit more external later. I don't want to promise any time, but yeah, I don't want to get my boss mad. So this is very, sorry, I'm going to close down a little bit of things, and I'm going to zoom in, because you probably can't see very well. There you go. Also, I noticed that the projector tends to be on the left side, on the right side, so there you go. That should be good. OK, so do not look at the errors above. Those are fixed. OK, like I said, I'm running an internet computer locally. So the way I did that, so we released today DFX 053, so that's what I'm using. And I just created this project, about an hour ago. I needed to make something work because this is a short demo, but normally you can get up and running in like 15 minutes. I just didn't want to spend your 15 minutes looking at me debugging stuff. And so I used DFX to start. Oh, I probably should zoom this one too. I used DFX to start the local replica. And so you're going to see this. So it pings it. It starts. You can see that there was a checkpoint. So we already had a state. That was me earlier doing tests. But essentially, every time you make changes on the internet computer, those changes are saved into a state. And then when you restart it, it keeps the same state. And the state is basically your memory. So if you have like a list of what we're building here is going to be a phone book. So simple name, description, phone number. And when you use your memory and you save, for example, a new entry, we'll show you that. It saves it in a state. And if you restart your node, or if you add a new node, for example, it'll just keep up to date. And that state is automatically updated. So you don't need a concept of databases, for example, because every time you change your memory, you write into your memory, the memory will be persisted between different calls. And it's a very, very nice model that, like, once you start using it, you forget about the old way of doing things, really. OK, so let me talk a little bit about Motoko. So I have here the Phonebook example that I was talking about in Motoko. So this is Motoko code. I'm just trying to aim at the side here. So we're going to use a list. So we import from the standard library. There is a standard library provided by DFX automatically. And then we define a new type for an entry, for a phonebook entry. And we define a phonebook map as an associated list of a name to an entry. And so we just create, just like that, we create an empty phonebook here. And we have two public functions. So contrasted with the old world, before you had you open ports and you have a server listening on those ports, and then you're kind of responsible for everything that goes through those ports. And that's why often you need special software, not just for firewall, for blocking the ports that you're not supposed to show up, but also for managing the actual calls. In the internet computer, you just specify your API. So in this case, we have two public functions, insert and lookup. And that's all. That's all that people can call, actually. That's your API. That's what your server exports. That's what your app exports. That's what your service shows. And so we have an API for inserting. and we have an API for looking up names, essentially. And in addition to that, well, OK, so inserting, we create a new entry. And then we replace the entry if there is already an entry for the name. Basically, it's not just an insert, it's an insert or replace. But we replace it with the new entry if there is one. And then we set the new phone book because this returned a new phone book with the list appended. Is that a word? Appended. And so lookup is just basically find the first one where the name matches, well, where L and R matches each other, basically, when they're equal. And that's it. That's it for the Motoko part. So another thing that the DFX, that the command line tool allows you to do is, so you can canister install. It might already be installed, so it's going to tell me. Yeah, told me that it's already installed. Asked me what I was doing. I'm not sure. So so now we can actually call that API. So we call the phonebook canister. So a canister is basically your application. It's your code. It's your service. And it contains your asset, like front end pages and any images that you want or anything like that. So we call the phonebook. And then we're going to call its method insert. And we have this little syntax here for passing arguments that is a little bit like Motoko. So we use the syntax basically. So my function took 3 arguments, which was name, description, and phone number. All of 3 were strings. So some description here. And my phone number. Please don't call me. That's not even a valid phone number. There you go. That's not even a valid phone number. OK. And so what it does is it's calling. It returned nothing. And it called. So oh, you might have missed it. But essentially, it created a checkpoint before, did the transaction on the local replica, and then created a new checkpoint. So now, if I look up, so call, whoops, phonebook, lookup with Hans. There you go. So you can see that some description and 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0. And if I kill my local replica, and I do other things, I close my laptop, I go for a coffee, I come back, and I start it again, you'll see that it starts with recovered checkpoints 2319, which was the checkpoint that it created before. And if I look up now, it's the same. It's exactly the same. So it keeps the state between runs. And on the actual computer, it's going to keep the state between runs too. We just updated a new entry in the phone book, and everything was kept in order for you. So you don't see anything. So you don't have to use databases and inserts and like select and all those kind of things. You just use your data structures like you're supposed to, and it updates automatically. Now there is a front end as well, which is slightly. So there is a front end as well, which this is not going to work. This is going to fail like completely. How much time do I have? 5 minutes?
Yeah, maybe another 5, and then we'll leave some time for.
Yes, for questions. The funniest part. Yeah, I know.
Okay.
OK. So I know what my problem is that when I insert or I look up, I use essentially the number is an actual number. So if I parse hint, if I remove this, the insert should work. And if I look up, that should work too. But there was a problem here. So what was the problem? Cannot read property name of undefined. And that's because. So let's debug a little. I'm not going to go too fast. So I made changes to the front end, so I need to rebuild. And then if it builds, I want to canister install. Oops. Oh. So I want to send the canister code to the replica. So, so this is beta software. My safety goggles are on. You can see that the canister ID changed in between. We're trying to fix that so that you don't have to change your canister ID, because now the state changed, for example. So now I have to reload the state and everything. So this will definitely fail. But if I insert, this seemed to work, so that's good. And now if I look myself up, cannot read property name of undefined. And that's because entry is not an array. There you go. Oops. OK. So sorry about that. I am going to rebuild and reinstall. And again, like we're working on the developer experience. This is wonky a little bit. This is still beta software. We are every version that we release, we are making a lot of fixes, a lot of new features that make it easier for you. So I'm gonna. There you go. And if I look myself now, whoop. There you go. So as you can see, I found myself. I'm gonna zoom in a little, and then if I add another person, so Alexa is not Hans. And our phone number is different. It's not my phone number. It's not? I thought you had a 6-number phone number. Yeah. So now if I look up myself, I can find myself. If I look up Alexa, I'll find Alexa. So what I want to show you here is that this code is actually part of the canister itself. It's part of the assets. So it's all JavaScript. It's made with React. This took me half an hour to make the other day. It took me about 15 minutes to redo in the hall here. And it talks natively with the replica. So it talks natively with the internet computer. It establishes a connection directly and then do all the calls and everything. So really, you're not using any service like AWS. You're not using any service. You're not even using a web server locally. This is all done through the replica itself. So yeah, you can see the render here, which is all React code to render the table. I mean, I'm not doing anything fancy with this, but it worked really naturally. And so what you can see is that the Phonebook insert call is essentially just insert, like it's an actual, I'm just calling insert as if I was calling the Motoko code. And the lookup is actually calling the lookup here as if I was calling Motoko code, using the name and then getting an optional entry and verifying if the entry has been defined. So if the entry is not defined, it's just going to not work right now. Oh, yeah. Anyway, little bugs here and there, but you can see, and so the good thing here is if I kill this, and I refresh this, you can see this site can be reached. There's nothing, there's no magic here. There you go. I'm just restarting my replica. It could be hours, days later, it doesn't matter. My Phonebook is now available again. If I look for myself, it's going to be myself again. And if I look for Alexa, it's going to be Alexa again. So yeah, that was a short demo of the internet computer running locally. And I think we're at the point where we're taking questions, isn't it?
Yep.
Yeah.
Good job.
Cool. Thank you.
Phonebook is we have a Phonebook tutorial in our docs that you can actually go through and work on. And then another cool thing I forgot to mention is that LinkedUp, the app that I mentioned, is open source right now. And I am not a developer, but I can get it up and running with the node I can get it up and running really quickly, in about 10, 15 minutes, and I would encourage you all to give it a try. And we can always pass along some resources to Luke afterwards, so you can give it a try.
And if you have any questions, just welcome to our discourse, forum.dfinity.org, or just go through our documentation at sdk.dfinity.org. There you go. If you want to save a little bit of time, but yeah. Any questions? Yes.
The internet computer which you spoke about, is it a blockchain or is it like a decentralized network?
You want to talk to this?
Yeah, sure. So it's not really directly comparable to just a blockchain. We are using blockchain in the actual stack of the internet computer, but there are several other sort of layers that make up the internet computer. But we do have, a consensus protocol in the sense that you would think about how they're being used today.
Essentially, blockchain is a technology, and we're not basing. We provide consensus by using a blockchain, but the blockchain is never exposed. So really, you wouldn't even know. Although, it's never exposed. The normal user, but there are ways to look into blockchain to make sure that the code that is executed is actually the right code that you were supposed to execute. There are ways to validate that. But it's an implementation rather than a feature.
Any other questions?
Yes.
I know Dfinity has like a fellowship program, 12 months or so, and I know it's usually offered towards graduates or TAs type level. Would that ever be open, do you think, to underclassmen?
Yeah, I can actually talk about that.
Go for it.
So actually right now we're in the process of sourcing 3 fellows, so one for the Bay Area, one for Boston, and then one for London. And this is actually a new fellowship program. So in the past we offered scholarships, and I think this is maybe what you were thinking about. We offered it to some graduate research, also undergraduate research level students, but this new fellowship is actually focused on internet computer education. And so it's basically a part-time fellowship where you can help support curriculum development for the internet computer and distilling down some of the technical information into what would be almost like a CS curriculum. And so that the applications are open for that. If anybody's interested, you should check it out. It's on our careers page. Yep. And that is open to undergraduates, so there aren't really restrictions.
Cool. You're stuck with it now.
One more question. So we've talked a little bit in class about scalability and performance issues around the blockchain, right? How the number of transactions per second is not yet there to meet real world needs, as compared to Visa and whatnot. Do you have a solution for that since you're blockchain based, or are you not thinking about it because your workloads are different and the architectures, doesn't impact it, or how are you thinking about performance and scaling?
Yeah, I would argue that those are sort of the most important factors of the internet computer. So the way that we're actually designing this, virtual public computer is so that it will provide equal or better scalability and performance to what we're used to today with centralized systems. So that's definitely at the forefront of the design. And I think we actually have the video of the Davos demo live that we can send it to you, but you could see in that demo that with this demo net, it was basically instantaneous and very similar to the performance of a centralized site. So
There were latency, but essentially we didn't go into the details, but there's 2 types of calls. There is one where your memory is read-only,
Yep.
and there is, thank you. And there is one where your memory is read-write. And the only one that actually needs to go through, a checkpoint and actually update your state is the one where your memory is read-write, correct? So if you only need to read the data, if you have an algorithm that only needs to read, like the lookup, then it can be instantaneous because you don't have to ask for consensus. You can just ask a few, and then you only have your latency. And then you can compare the answers from the few and just verify that the answer is correct. And so this is pretty much instant. And I think this is, there are some models for other blockchains that have that, but you have to basically provide your own client and keep it up to date yourself. So.
Yeah, if the use case is read-only, not an issue, right?
Exactly.
If you need to write, you need to get around the protocol issue.
Yes, but surprisingly, like most access on the internet are read-only. If you go to Facebook front page, it's read-only. Really, you only query your contacts for the wall and then the events and all that. It's only if you create a new post that it might take a few seconds, but in most cases, we didn't find that it was.
My last comment on Facebook is from 2015. So there's no right for me. So
I can tell you it's not taking five years to get consensus, so that comment will be online.
perfect. Any other questions?
I had a question. What do you see as kind of like the beachhead market, maybe for these types of applications that don't require like the AWS and these, kind of legacy infrastructures? Like, where do you guys see like your first opportunities?
Yeah, I mean, I think there are a few areas. I think, the enterprise space is actually really interesting. We didn't go into like sort of that realm within this presentation, but just the costs associated with maintaining the complex enterprise systems today is just astronomical. There was just a Gartner report that like the IT stack and it was just released in January, is going to cost $3.9 trillion. And a lot of that cost actually goes towards just maintaining these systems because they're so complex. And so we really think there's an opportunity there for enterprise systems. And then when you layer in sort of the ability to have kind of cross-industry collaboration, that gets really interesting too. And then we kind of see a whole other bucket of sort of these open internet services that we're really excited about. So LinkedUp was just sort of one example that we put out as a demo to kind of inspire people, but we hope that there will be open versions of basically everything that we know and love today. And we think that is totally possible. So I think those two are probably like the biggest opportunity areas that we see, yeah.
I want to point out, just 1 second, I want to point out that just because something is open doesn't mean that it's free necessarily, and there is a business model where you can make open services and still like make money and pay your employees, basically.
Right.
Yeah.
With some sort of token economy.
Exactly. You can charge. You could have a Facebook, like just a social media graph, a social graph with some algorithms on top of it or something, and then you can charge for people to query that without worrying too much about who can query. Like you can set your own governance rules, and that's where the rules are different than before, is in that like if you charge per transaction, that those transactions are kind of automated by the system itself. And you cannot just close your API like saying, well, I don't want that guy, for example, or there's a competitor that I don't like or something like that, which is totally possible today. Like if Google decides that, Yelp is not a thing, well, it just can push it down the search results. And everybody knows that like the place where people never look is the second page of Google, really. Like that's the worst place to be.
Yeah.
And back to kind of the platform risk that we talked about earlier, like if you actually do some research on when those companies pulled their APIs, they all cited kind of competitive projects and use cases as one of the reasons. Like they openly cited that some of these startups were looking a little too close to what we were going after. Like LinkedIn, for example, saw that there was a chat application that someone had developed and it was potentially competitive to something that they wanted to release down the road. So there's just like, there's not that ability to do that in an open system. Where there still, could be business models. It's just you're not sort of stifling that innovation or access in the same way.
Thank you.
Great.
Wonderful.
Thank you.
Thank you.